Hey there, welcome to a video discussing pages 7 through 10 of our Chapter 3 notes. More specifically, this will be dealing with sections 2.8 and 3.3. Actually, I have it labeled right there, so sections 2.8 and 3.3. So this is about linear system inequality. So we're going to be taking what we know about linear functions, like graphing lines, but change the equal sign to an inequality and then see how that's going to look a little different. So let's start by graphing this inequality. So what you want to do is treat it like y equals negative 2x minus 5. But add in a couple more steps. So you can see here, we should start with the point, a y-intercept, which is negative 5, because this isn't y equals mx plus b form, of course, right? Our slope is negative 2, so go down 2, start negative 5, go down 2, right 1. And then before I connect those 2 points, we need to determine, these are the couple more steps, a solid or a dotted line. Now here's the deal. Because it's less than, you're going to do a dotted line. The reason why it's dotted, we don't want to include points on the line as a solution to the inequality. So, for example, 0, negative 5 is a point on this line. Well, if you plug in negative 5 for y and 0 for x, you're going to get negative 5 is greater than negative 5, which of course is not true. If it's greater than or equal to, then we'll do a solid line because any point on the line would then satisfy the inequality. But any points on the line here won't satisfy the inequality, so we don't want it. So that's why we do a dotted line. So something to keep in mind there. Then for the shading, we're going to shade above. So greater than will be above, less than will be below. That should be pretty intuitive. But the reason why that's true is because we have y isolated. And y is a vertical coordinate. So these are questions I'll pose on the Google form. Why do we shade above or below? Why do we dot or solid? I want to make sure you think carefully about that. And we're going to see this again in the next few examples. But again, if it's greater, you go above, less than you go below. And the reason why you go above is because y is a vertical coordinate. And of course, if y is more than something else, then you want all the y values to be bigger. Plus, if you test 0, 0, 0, 0 would satisfy the inequality. If it didn't, then of course you go the other direction. But really, again, y is a vertical coordinate, and because it's greater, you want y values to be more than that. So our shaded region represents all points that satisfy the inequality. That's what the shaded region represents. So any point in the shaded region will satisfy the inequality. Y is greater than negative 2x minus 5. So now let's do this again, but let's do it for 2 lines. So we have the same one as before. Very easy. Dash line. And then I'm going to do green for the other. Then the shading. I'm going to shade below the green line. So I'll do red for that. I'm going to shade above the blue line. So notice I see this overlapping region that's kind of turning red. That's going to be the solution region, or the overlapping shaded region. So any point in that overlapping region will satisfy both inequalities. So that's going to be, again, our solution. So for example, 6, 0, see how that's in the overlapping shaded region. If I plug in 6 for x and 0 for y into each of the inequalities, each inequalities will work. So I guess it's called the Fantastic Four. I didn't make that up, but you know, straight from the comic book or movie, I guess. So let's try some more of these. So go and try number 3 on your own. Go and pause the video. See if you get the same thing I do. And I'm going to do it right now, but pause the video. Okay, the overlapping region is that little triangle right there. We had to be below y is less than x. We had to be to the left of x less than 6. We had to be above y is greater than -1. So it's actually contained in that triangular region. So anything in that triangular region would satisfy each of those inequalities. We do see that 2, 0 kind of fits in that triangular region that has all the overlapping shaded regions. And 2, 0 would satisfy each of those inequalities. So that's that one. This one here, you may want to isolate y to make your life a little easier. What did I just do? Okay. That's easy. The other one's going to be a solid line down 2/3. So this is interesting. These are going to be parallel lines. And we're shading above the red line. We're shading below the black line because we have less than for the black line. With y less than -2, there's x plus 2. Now in this case, shaded regions don't overlap. There's nothing in common. So we're going to say this is no solution because no points that would make both inequalities work. At the same time. Okay, here we're asked to go backwards. This shouldn't be too bad. Y equals mx plus b, but we are going to have an inequality, mind you. Looks like our y-intercept is 2. And our slope looks like go up 2/3. you're shading below. And it's a solid line. There you go. So here, your y-intercept is 3. It looks like your slope is 2. And you're going above. So it gets to be pretty simple once you think of it. Y equals mx plus b. M's your slope, b's your y-intercept. Here, y-intercept of -3. It looks like it's a slope of -1. And again, you're going above it. So greater than -x minus 2. So that's going to be the combination of all that. Yeah, you can kind of see if there's a point in common like -2, 3. And kind of work that out. So yeah, that's what we got there. So 7 and the rest of these here, these are a little more complicated. One of I ask that you do is that you try these at home as practice. And we'll actually talk about the answers for this in class when we meet again. I don't want to make this video too long. So try this at home. If you're stuck, that's okay. We can talk about it on Monday. And I think that is all I want to talk about. And lastly, I'm going to give my Stanford prediction. Okay, I should not spell Stanford. I can't believe I put a D there. Must be Friday. Stanford, let's say 27, Notre Dame 24. Yeah. We can go Stanford on this one. The one by a field goal. Okay, well, have a great weekend. I'll see you guys later.